When Ariel, the little mermaid, said, "Look at this stuff, isn't it neat?" Do you think she was talking about medications or chemicals? Over 100 pharmaceutical remains are detected in our coastal waters from harmful wastewater treatment practices. Pharmaceuticals are not our only worry. Pollution from plastic chemicals, pesticides, and other micropollutants are changing the chemical makeup of our oceans and waters. Enter Pharem, a company developing an enzyme-based water treatment technology that removes harmful organic compounds in wastewater treatment plants. Hello, I am your host, Mike Lake, and in this preview, I will be talking with Christian Ryen, COO and co-founder of Pharem Biotech, a green and necessary solution to many of our water pollution challenges.
Innovation, resiliency, discovery. Join Mike Lake, President and CEO of Leading Cities, as we explore the technologies shaping the possibilities of our future with a preview of tomorrow.
Hello and welcome, Christian. Thank you so much for joining us today on Preview of Tomorrow. And of course, I want to thank all of our listeners and viewers as well for joining us for this episode. I'm really thrilled to introduce you to Christian Ryen. He is the COO and co-founder of Pharem Biotech, a company that has developed efficient and cost-effective enzyme-based water treatment technology, which can be applied at municipal wastewater treatment plants, industry processes, or other water environments to tackle pollutants. Now, Christian, before we really dive into everything that I just said, and understanding both the problem that we face in terms of water pollution and this opportunity to resolve it, tell us a little bit about yourself and how did you come to create Pharem Biotech?
Yeah, thank you, Mike. Okay, so my name is Christian, CEO and co-founder of Pharem. Have a background in chemical engineering, and I worked a lot with environmental tech such as clean tech and renewables in many years. Started Pharem, co-founded Pharem 8 years ago. I'll come to that a little bit more on how the history of the invention was. But very short, great passion for water. So that's one of the key aspects of why Pharem exists is the passion of water. We really believe that there is technologies out there that can benefit the sustainability of clean water in our society.
And so certainly, let's face it, I think we've all heard of water pollution. My sense is that most people probably think of, chemicals being dumped by the barrel full into waterways, whether it's a river or a pond or ocean, whatever.
Yeah.
But the reality is there's a lot of ways that our water is being polluted, from basic, atmospheric precipitation and travel, runoff in our waterways, direct disposal, as I mentioned. And then, of course, it takes on all kinds of forms, from simple things that we all do every day. Can you give us a sense of just how widespread this source of pollution really can be?
Yeah, of course. I mean, we look mainly at water pollution, but there, of course, we have air pollution and any kind of pollution. But when we look at water pollution, we need to look into our society and how it works, and we mainly focus on organic pollutions because we use a lot of organic chemistry into our products that we use on a daily basis. So a lot of organic waste to water come from households, or it comes from offices or everyday products we use. It could be medicines, it could be personal care products, it could be household care products. Yeah, I mean, there is a wide range of chemicals that we use, and these are collected when we take a shower, when we go to the bathroom, whatever. It's collected into the sewage, and it's transferred through our sewage to our treatment plants, where they actually in the end, some of them end up in nature, and that's where we have our focus. It's the organic micropollutants that are not taken care of in the treatment plants today.
And these microorganic pollutants, I mean, how plentiful are they in our water sources?
Okay, so many times, I mean, you talk about dumps. Of course, if you dump 100 liter of something into a lake and it's very toxic, it's going to have a huge effect. But what we look at is long-term effect, or long-term negative effect of toxic compounds. So it could be plastic chemicals. Plastic waste, that you have microplastics, but there is also something called plastic chemicals or connected to plastic chemicals, which have hormone disruption capabilities. I mean, they disrupt ecosystems. We even think they disrupt our own human potency and male fertility. We have all the kind of medicines. Antibiotics is one that is highly discussed globally. Our release of antibiotics into the sewage and later on to the nature is one of the biggest concerns when it comes to antibiotic resistance development that we see in nature. So I would say it's severe.
Yeah, no kidding. And I mean, you mentioned the chemicals that are used commercially. It's like, commercially speaking, just alone, we're talking over 100,000 different chemicals.
Many organic chemicals. Yes, it's a massive amount of organic that have biological activity that is of a certain concern when it's released to nature.
Yeah. So when we think about our water, clearly, and we've talked about this on Preview of Tomorrow. I mean, yes, our planet is covered in water, but really only about 1% of it is drinkable, and some predict that in as little as 18 years, we might not have any drinking water available.
Yeah.
So when you talk about that challenge on the horizon, how critical or how critical is this issue that we're facing in terms of the polluting these water sources?
I think it's severe. I mean, I have a passion for water, and I think it's severe. I think one of the challenges we have is that we rely heavily on that the wastewater treatment plants are equipped with the treatment technology that have to be implemented to actually take care of all the pollutants, but they are in reality they are not. So we are in a mismatch, I think, where we think we have protecting our waters, but the treatment plants are not equipped to take care of all the waters or to treat all the pollutants, and therefore we are continuously polluting our fresh water, since we have recipients in lakes and rivers and so on, and that will end up in our groundwater and so on. So there is a huge pollution source from households and cities and so on.
So let's talk now a little bit. I mean, before we even get into the solution, I do want to just put a fine point on the fact that, frankly, we're all a little guilty, or a lot guilty, in terms of generating all this pollution, whether intentional or not. So we all have, our own bit that we can do to help. But tell us what Pharem is doing to help, because you're doing it on a much grander scale than any of us.
Yeah, maybe. I think it's a good point. No one can do everything, but everyone can do something, and that is a very good statement when it comes to choosing products with a better sustainability profile or whatever focus you can have. So Pharem, I mean, today there exists a lot of treatment steps that you can implement to a treatment plant to actually treat organic micropollutants. But many times these treatment steps they rely on older technologies. They are sometimes only having one single treatment mechanism, which makes them not so flexible towards coming pollutions or coming new organic pollutions. and they are also many times a bit expensive to implement, and this create barriers. This create barriers so that many treatment plants do not have the capability, and they are hesitant to actually implement these kind of technology. It's too costly for them. So to change this course of treatment of organic micropollutants, the market should be presented with new and disrupting technology, and that's where Pharem have taken that position. So we developed a treatment technology called Somatic, and this is the enzyme-based treatment step, and that is to address simplicity, address costs, address flexibility in the treatment towards organic micropollutants. So what we did here is that we combined this kind of enzyme development, material modification, and immobilization methods to create a highly efficient treatment step, which is very simple. We call the treatment step or treatment material somatic sand, because you in the end, even if though we have advanced technology areas, our customers are presented with a sand-like material, which is very, very easy to use. So we end up with a flexible treatment technology, simple to use, have a very high efficiency, and it's a low cost operation, which is necessary for the market to actually start implementing this kind of treatment step on a broader scale.
And so walk us through a little bit, how the product is used. As you said, there's a lot of complexity behind it, the chemistry, the R&D side of things. But, in the end, we're talking about a sand-like substance.
Yeah.
So if I have a bag of this type of sand, what do I do with
sell
it?
No, so let's say, to really understand somatic, you need to understand enzymes. So the basic of enzyme is that they are catalysts, which means that they are not consumed in a reaction. They are making reaction happen. So you can actually, and enzymes exist in all living things, and they exist in fungi to cells in our bodies, and they perform all these kind of important reactions.
Mm-hmm.
But you can use this. So you can use this kind of knowledge to select enzymes to target organic micropollutants in this sense, and combining our tech, we then select enzymes to target these, and we add them to the material. So you should think it like this: there are a billion of enzymes, and every enzyme presents us with an opportunity to make use of a certain treatment mechanism. So Pharem have developed the methods on how to identify which one we should use for specific treatment goals. So we program the treatment we want based on what need we have, and that is very, very unique to enzymes and the enzyme tech that we have developed. So let's say, I'm going to give an example. So let's say we are at the municipal and we target a couple of hundreds of organic micropollutants. Then we can create an enzyme mixture that is focusing on these compounds, and we can add this to the material, and then we let the water flow through, and then the treatment is happening already with a simple flow through of the water.
So essentially, the sand is a two-part filter. It's the water flows through as a traditional filter, but as it's flowing through, these enzymes, like an army of micro-sized warriors, are attacking all of these pollutants.
Yes.
And creating that reaction that basically neutralizes the pollutants.
Yes, exactly. So it breaks it down to non-toxic compounds on products. Yeah.
That's amazing. So this can easily then be added, is that right, to just about any existing process?
So basically, when we look at municipal wastewater treatment plants, it's a polishing step, so it's the end of the treatment steps or a treatment facility, and that's where everyone looks at the treatment. All treatment technology look at positioning them as a polishing step, because that's where we have the cleanest water and where we have the rest of the organic micropollutants that we want to target. So we just put it there, and we let the water flow through the sand filter. And since the industry and the wastewater treatment industry is so familiar with the sand-like material, it's very, very easy to operate, and it becomes it's no complex installations, or I mean, you can have it in a container or in a bed or in a column. It's based on your likings. But the beauty here is with Sumatic is also that we can target specific challenges at the industry sites. So let's say you have a process stream that has certain challenges caused by organic compounds, then we can tailor and select the enzyme based on that need, and we add those enzymes to the material, and then you have a very high efficient or a very high efficiency for your specific compounds, and that creates a very cost efficient treatment step for industry use, which is very interesting.
So the key point here is that even after water has been treated and is being released back into the environment, the reality is it's actually not all that clean, or not always
true.
clean.
Yes.
And so what you've done is created a way to clean it up at that final stage and put back clean water, truly clean water. So let's look forward 10, 20, 50 years down the road here and assume that in every use case there can be, that Pharem technology is being applied. What does that mean? What does it mean for those users? What does it mean for the environment? What's the impact that we can expect or hope for?
Yeah, so let's that's a good question. Let's say that we implement Sumatic in all wastewater treatment plants in the world, right?
Yep.
Then we don't have to. I'm going to give you some examples. We don't have to care so much if we can eat this fish or not. We are fishing in a city near, or a lake near the city. We don't have to care so much or we don't have to care about, can I drink this water or not, or have it been polluted by PFAS or something that is very relevant today, we don't have to care if I swim in this water, do I have a long-term negative effect on my potency or something like that. I mean, those current concerns we can take away if we implement them. Another thing that's very important is we don't have to care so much about antibiotic resistance, because we haven't developed or released so much antibiotics to the water. A huge negative effect about antibiotic resistance is that we miss the fact that the antibiotics not just used when you have a certain bacterial infection. It could be also after a surgery, or it could be something like that. And that's very important to realize, that perhaps we cannot in the future, if we don't take care of this problem, we can't do certain surgeries and so on. And that's a great challenge we are facing.
So there's so much more to cover, but listen, our time is already up, but I do want to know, for all of our listeners and viewers who want to understand this a bit more or get in contact with you, what's the best way for them to do that?
You can reach me on LinkedIn. My name is Christian Ryen. You can also send me an email at christian@pharem.se. It's with a PH, so Pharem with PH. And I happily return your call or answer your questions. Enzymes will substitute chemicals in the future, and that's where we're headed.
Well, Christian, thank you so much for joining us on this episode of Preview of Tomorrow, and thank you for the work that you all are doing to make our water cleaner, safer, and really living up to the reality that most of us perceive to be true, that our water is safe.
Yes, thank you, Mike. Thank you for the opportunity to be part of the podcast, and looking forward to continue the work in AcceliCITY.
And thank you for tuning in to this episode of Preview of Tomorrow. Listeners like you are essential to advancing our efforts to drive resiliency and sustainability for all. I ask that you give us a rating on Apple Podcasts or whichever streaming platform you prefer. Your feedback helps us to grow and share these brief previews of what life in the future can be. In addition to thanking our guest today, I want to thank Peter Roy and Demetria Bridges for making this podcast possible. If you enjoyed this episode, please subscribe and encourage others to also join us each week in previewing the possibilities of tomorrow.
Preview of Tomorrow is brought to you by Leading Cities, a global nonprofit driving resilience and sustainability for all by unleashing the potential of the world's cities. Join them at leadingcities.org.